going to spend a little bit of time reviewing the amino acids and the different categories in which we can know them or think about them, some mnemonics to help remember, and just other information related to the amino acids that may be useful as we go along. So one of the ways we can categorize amino acids in different ways, but some of the primary ways in which we can categorize them or know them is by their polarity and by whether they're hydrophilic or hydrophobic. And so we're going to look at the nonpolar and hydrophobic amino acids versus the polar and hydrophilic amino acids. So when we're looking at this, we got to remember that hydrophobic is, when you have a phobia, you're afraid, you don't like something. So the hydrophobic amino acids don't like water. The hydrophilic amino acids, philia, they love water. And we want to remember in terms of how they're categorized is that likes generally likes. So water is a polar molecule. So all the amino acids that are going to love water are going to be polar. And the ones that don't love water are going to be nonpolar. So for the nonpolar amino acids, I have a mnemonic for both of these for knowing both the nonpolar and the polar amino acids, and the actual repetition of these mnemonics each have their own audio video in terms of repeating it and learning it. I think they each have it got sung through 3 times each. So if you're to review these ones specifically, just go to the audio for Nonpolar Anna, the Hydrophobe, and Polar Nadine, the Hydrophile. But here, going over it briefly, the mnemonic to remember the nonpolar hydrophobic amino acids is Nonpolar Anna, the Hydrophobe, good Anna, values, love, prosperity, morals, wisdom, friendship, and integrity. And this is using the symbol for each amino acid. And going by those symbols, we have good, so G, Glycine, Glyg. We have alanine, Alaa. We have valine, Valv. We have leucine, Leul. We have isoleucine, which is Ilei. We have methionine, which is Metm. Proline, which is Prop. Phenylalanine, which is Phef. And tryptophan, which is Trpw. For the polar and hydrophilic amino acids, I have polar Nadine, the Hydrophile. The mnemonic for this is Nadine's quest started through years carrying dark energy and kissing rowdy hobbits. So first one is asparagine, ASN, letter N, glutamine, GLN, letter Q, serine, SER, letter S, threonine, THR, letter T, tyrosine, TYR, letter Y, cysteine, CYS, letter C, aspartic acid, ASP, letter D, glutamic acid, GLU, letter E, lysine, LIS, letter K, arginine, ARG, letter R, and histidine, HIS, letter H. We can also categorize amino acids by their charge, their type, and their structure. So the acyl amino acids are going to be glycine, alanine, valine, leucine, isoleucine, methionine, and proline. The aromatic amino acids are going to be alanine and tryptophan. The aliphatic amino acids are going to be leucine, isoleucine, valine, alanine, proline, and methionine. Aliphatic is just where the protein side chain has only carbon and hydrogen atoms, except for methionine in this case. We can also categorize them by their charge. So we have the neutral amino acids, the acidic amino acids, and the basic amino acids. The neutral amino acids are going to be asparagine, glutamine, serine, threonine, tyrosine, and cysteine. The acidic amino acids are going to be aspartic acid and glutamic acid. The basic amino acids are going to be lysine, arginine, and histidine. We can also know there's also special cases of amino acids that we need to be aware of. So we have the ones that are helix breakers, and so for those we have two. We have proline and glycine. Generally, when we're asked about which amino acid would be likely to break the helix, more likely than not, they're asking about proline. But if it's not specified, if there's not enough information given in the text, I think for the most part, we're not going to be asked to identify which one would break it, because both glycine and proline can act as helix breakers, albeit proline is decidedly more of a helix breaker just because of its shape. Glycine can cause some kinks in the chain because that hydrogen has a free rotation. But just be aware that those are the helix breakers, but generally the one that is more normally called for that is going to be proline. The average weight of amino acids is 110 Daltons. We can also know the biosynthetic precursors. So tyrosine is a precursor to epinephrine or no epinephrine biosynthesis. There are also 7 ionizable amino acids, and these amino acids are generally the ones that the MCAT tends to use. These come up often just because they're ionizable, so they can be used in different ways. And the mnemonic I have for this are the ionizable sext 7. And that's really just for mnemonic purposes only, based on the letters and the order that these were put in. So the mnemonic to remember the ionizable sext 7 is going to be: don't ever claim your horny, kinky, or raunchy. Or I guess I didn't put or in there. So don't ever claim your horny, kinky, raunchy. And that's just for mnemonic purposes only. So to start off, aspartic acid, glutamic acid, histidine, cysteine, lysine, tyrosine, and arginine. Those are going to be the ionizable 7. They're important to know because they are ionizable, and generally, they can gain an electron, they can lose an electron. And just because they already have charge, so they don't all have charges. The aspartic acid, glutamic acid has charge. We have lysine. Well, the basic. This includes, if you remember that the basic amino acids, the acidic amino acids are included in that. And then we're also including tyrosine. I think I'm missing one. Oh, cysteine. And cysteine is also important to remember because of disulfide bridges. It's involved in making disulfide bridges, and 2 cysteines make 1 cysteine. We can also think of amino acids by ketogenic, and so the ketogenic amino acids are going to be lysine and leucine. And when we're looking at ketogenic or gluconeogenic amino acids, that's going to be phenylalanine, isoleucine, threonine, tyrosine, or tryptophan. Amino acids can also be glycosylated, and the amino acids that can be glycosylated are asparagine, serine, and threonine. Amino acids can also be involved in ubiquination, and so that's going to be lysine that's involved in that. Amino acids can be phosphorylated, and so the amino acids that are involved in phosphorylation are going to be serine, threonine, and tyrosine. If you're thinking about this, another way to remember that is that they have a hydroxyl side chain that can be phosphorylated. Amino acids can also be carboxylated, and for that we have glutamate. The carboxyl group and glutamate, a glutamate can have a carboxyl group can be added to it. We can also remember amino acids by which ones contain branched alkyl side chains. So that's going to be leucine, isoleucine, and valine. We can remember amino acids by which ones have nucleophilic side chains. The amino acids that have nucleophilic side chains are going to be serine, threonine, cysteine, tyrosine, and lysine. Some amino acids make substantial contributions to steric constraints due to their large side chains, and so we can learn also which ones make these substantial contributions to steric constraints, and that's going to be phenylalanine, isoleucine, leucine, lysine, methionine, arginine, tryptophan, and tyrosine. And then of the amino acids, 9 of them are essential amino acids. This means that we can only get them from our diet. And the mnemonic I have for this is the idea that victory is essential. And the mnemonic goes, hey, I like kissing more from the winning victor. And so that's just to remember the 9 essential amino acids, the ones that we can only get from our diet. And that's histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. Again, the mnemonic is, hey, I like kissing more from the winning victor. So this just really goes to show all the different ways that we can think of amino acids and categorize them, and to kind of remember their different functions and the different ways they can be used and utilized in the body, because that's going to be important as we go along. We can also, I touched base on the 9 essential amino acids. I'm not entirely sure how much we'll need to know about what each one does, but I think it is helpful for understanding some of the functions and also potentially how it may be included in passages. But generally, the passages will have the knowledge that you will have the background or whatever they want to include for your knowledge, for understanding. But so histidine produces histamine, and histidine is vital to the immune response, to digestion, to sexual functioning, to the sleep-wake cycles, and histidine maintains the myelin sheath. Isoleucine is involved in muscle metabolism. It is heavily concentrated in muscle tissue. It is important for immune function, for hemoglobin production, and energy regulation. Leucine is critical for protein synthesis and muscle repair. It helps regulate blood sugar levels. It stimulates wound healing and produces growth hormones. Glycine plays major roles in protein synthesis, hormone and enzyme production, and the absorption of calcium. Lysine is also important for energy production, immune function, and the production of collagen and elastin. Methionine plays an important role in metabolism and detoxification. It's necessary for tissue growth and the absorption of zinc and selenium. Phenylalanine is the precursor for neurotransmitters, tyrosine, dopamine, epinephrine, and norepinephrine. It plays an integral role in the structure and function of proteins and enzymes and the production of other amino acids. Threonine is the principal part of structures such as collagen and elastin. It's part of skin connective tissue. It plays a role in fat metabolism and immune function. Tryptophan is often associated with causing drowsiness. It maintains proper nitrogen balance. It is a precursor to serotonin, the neurotransmitter that regulates appetite, sleep, and mood. Then there's valine. Valine helps stimulate muscle growth and is involved in energy production. There's mixed feedback in terms of whether or not we need to have the pKa memorized, the pKa of the amino acids memorized. When I was researching the amino acids, it seems like if we are going to memorize the amino acids pKa, it's really only handy for the ionizable sext 7, again, because they're ionizable. So these are the groups that they have side chain groups that can lose or gain atoms at a specific pH values. And those tend to be the 7 amino acids from the ionizable sext 7. So if we're thinking of the alpha carboxyl group on an amino acid, that's going to have a pKa of about 3.1. If we're thinking of the alpha amino group on an amino acid, that's going to have a pKa of about 8. The aspartic acid is going to have a pKa of about 4.1. Glutamic acid is also going to have a pKa about 4.1. Histidine has a pKa about 6.0. This is important to note because histidine is generally found pretty close to physiological pH in its current form. Cysteine has a pKa of about 8.3. Lysine has a pKa of about 10.8. Tyrosine has a pKa of about 10.9. And arginine has a pKa of about 12.5. And so those were organized in order of acidity. And if they're organized in order of acidity, the mnemonic changes for their singular alphabetical letter to spell DECYHKR, which I think the mnemonic I made for that was don't express hate, create your kindness right. And that's the ionizable sext 7 organized according to pKa values. Some general notes on pKa. If pH equals pKa, 50% of the molecule exists as an acid and 50% of the molecule exists as a conjugate base. If at a pH below pKa, the acid form of the molecule will predominate. If at a pH above pKa, the conjugate base of the molecule will predominate. This is why amino acids exist with the carboxyl group deprotonated and the amino group protonated at physiological pH, which is 7. The net charge will depend on the charge of the side chain group. The carboxyl group and the amino group charges have a net 0 charge. Let's see. I also have some notes on for the ionizable sext 7, which are the 7 that we need to know that are potentially going to be active or reactive. What form they predominate in. So aspartic acid and glutamic acid are going to predominate in the in the anion form. Histidine is very close to physiological pH, which makes it a good amino acid to have at the active site of proteins, as it can both stabilize and destabilize the substrate. So that's important to know. Histidine can readily accept or donate H atoms. These are important traits. These are important things to know about these amino acids, specifically the 7. So cysteine can form disulfide bridges at very basic pHs. The sulfur anion form predominates and is able to form bonds with positively charged species. So then as we look at lysine, tyrosine, and arginine, these three, because of their high pKa values, Lysine, tyrosine, and arginine will always exist in their acid form at physiological pH. At physiological pH, lysine and arginine will be able to form ionic bonds. Tyrosine will act as a hydrophobic molecule, and it will be found inside the protein structure, and it will interact with the nonpolar amino acids found inside the protein. And I'm just checking to see if there's any more. So that's most of the highlights for some of the amino acids. I think that will do it for this note review. I may or may not do one that's just specific to memorizing the amino acids and their symbols. That might be its own note review, so I can just listen to the amino acids to get their symbols. I know I did it once through on this audio, so potentially another audio video.